Sample problem 7.06. In the given figure, a cumin canister of mass m equal to 0.4 kilogram slides across the horizontal frictionless counter with speed v equal to 0.5 meter per second. It then runs into and compresses a spring of spring constant k equal to 750 Newton per meter. When the canister is momentarily stopped by the spring, by what distance d is the spring compressed? So in this question, we have to find the answer for the compression value of the spring. So let's see the figure here. We have an object which is a cumin canister, and this object mass is 0.4 kilogram. And this will have the speed in this direction of 0.5 meter per second, and it will come and hit the spring. So when it will come and hit the spring, what will happen? The spring will be compressed up to this level, right? And the most important thing, the spring constant value is given here as 750 Newton per second. So they ask, when this object will come and hit, what will happen? The spring will compress, and after compress, what happened? The object stops. By that, what we have to find? We have to find how much the spring will be compressed. That means the value of the d we have to find. Clear? So first of all, let's write the given first. What is given in this question? We have the mass of the object, which is 0.4 kilogram, and also the speed of the object, which is 0.5 meter per second. And then the spring constant value k is given, which is 750 Newton per meter. And by using this, we have to find what is the compressed value. So let's take the d value. Here d is the compressed value. Or if you have any confusion, we can use the letter x. That's up to you. And the most important thing, the surface is a frictionless surface. Clear? So now, how come we have to find the answer? We have to use the conservation principle. By using the conservation principle, we have to use the formula of kinetic energy as well as the spring potential energy. So as we already studied, the kinetic energy formula is half mv square, which is equal to the spring potential energy is half k x square, but here x is the compression, so we have to use, in place of x, what we have to do? We have to use d square. So this is our conservation principle. That means the conservation of energy principle. So now you have to substitute the value. So we can cancel half left hand side and the right hand side. And by using the left hand side and the right hand side, we have to first rearrange this equation. When you rearrange this equation in terms of a d square, so we will get d square, which is equal to mv square divided by k. And we have to take the square root on both sides. So when you take square root on both sides, what you will get? D, which is equal to a square root of mv square over k. Now we have to substitute the value here. So when you substitute the value, what we will get? The mass of the cumin canister is 0.4 kilogram multiplied by the speed of this object is 0.5 meter per second. That means we have to square this, divided by the k value is 750. So we have to find. So if you want, you can just take the v outside, because this is v square, half of v square is v, but I just take everything inside. That's the reason I'm just using the speed square. So let's see what is the answer. So here we got the answer for this, the compressed value of the spring. That means what is this d? The d is the compression of the spring, right? D is the compression of the spring. So we have to find this answer. So the value of the d, which is equal to 0.012 meter, 0.012 meter. So this is the answer for this question. That's it. Thank you.